Okay, so today we're going to be going over reflections, which is one of the many rigid transformations that we are going to be learning about. So when you think reflection, you might think about a mirror or the song for Mulan. So the reflection creates a mirrored image. And so right here, we'll get started with the notes. It says, in a reflection, a line plays the role of the mirror, and every point in a geometric figure is flipped across the line. So here we have an example of a reflection. I have line AB, and it's reflected over this line. So this is like the mirror, and it becomes A prime, B prime. That's what we call the A with the tick mark, B with the tick mark. It's A prime and B prime. And now for some vocabulary. AB is the line that we started with, and we call this the pre-image. The pre-image is what we start with. And then we mirror it over what's called the line of reflection. That's what it reflects over. And after we reflect it, it becomes what we call the image. So we have the pre-image where we start, the line of reflection that we mirror across, and the image itself. Now it says connect A to A prime and label the intersection of the line of the reflection with A prime as Q. So I'm going to connect these two, A and A prime. So the pre-image point to the image point. And I'm going to mark their intersection with the line of reflection and label it as Q. Now it says, what do you notice about AQ and QA? So and QA prime. From A to Q and Q to A prime, these two pieces are actually congruent. They are equal. Another thing that's true is that A prime and this line that Q is on meet at a 90-degree angle. They are perpendicular lines. It says now repeat with B to B prime. So I'm going to use my ruler again and draw the line between B and B prime. And now that intersection we will label as Y. Now again, this new line that we drew has created two congruent segments, and these lines meet at a 90-degree angle. So when we do this, we create Y, which is congruent to B prime Y. We create two congruent segments. All right, what are three congruent statements that we can write from the picture above? So what are three things that are congruent? Well, we just said A to Q and A prime to Q are congruent, so I'll list that one. AQ is congruent to A prime Q. We wrote one here in that second question about BY, line segment being congruent to B prime Y. And we also have two lines, so line AB is our pre-image and A prime B prime is the image, and those two are congruent as well because this is a rigid transformation, and with rigid transformations they never change the size, only the location. So our original and the new image should be congruent to each other. So we say AB is congruent to A prime B prime. Those two lines are also congruent. Okay, so now we've looked at those congruent pieces. Next it says, what is the relationship between A prime and line segment B prime? Well, notice both A prime and B prime are both perpendicular to the same line. So if any lines are ever perpendicular to the same line, then we can say that those lines are parallel to each other. So we would say line segment A prime is parallel to line segment B, B prime. All right, so now let's look at the major properties of reflections. There are two big things that we just saw today that are really important to remember. And the first one being that segments connecting corresponding pre-image and image, that's the before and after, pre-image and image points are perpendicular. Remember, we can do the upside down T for perpendicular, or perpendicular to the line of reflection, and that's the line in the middle. So this is the first property we saw, that we found that A prime was perpendicular to this line, and so was B prime. The second property also has to do with the lines. It says the line of reflection bisects. So remember, bisect means cuts in half. So bisects segments connecting corresponding pre-image and image points. Well, what do these two things mean? So the properties of reflections, one says that this line will be perpendicular to the lines that connect the pre-image and image. And it also tells me that this line will bisect those same lines. That kind of sounds like one of the constructions we learned about. The line of reflection is a perpendicular bisector of all these lines. So these two properties really just tell us that the line of reflection is a perpendicular bisector. And we're going to use that property for the second section. It says use the properties of reflections to determine the location of the line of reflection. Now, just by looking at these two, seeing where the pre-image and image are, where do you think the line of reflection will go? If you said somewhere in here, you're right. That's the line that this image has reflected over. It's somewhere in here. But we're going to find where it truly should be. So I'm going to connect the pre-image to the image points for both C and E. You could do it for D too, but I'm just going to focus on these two. And now if I need to find the line of reflection, remember we said the line of reflection is the perpendicular bisector of the lines that connect the pre-image to the image. So I'm going to actually do the construction. So I'm going to do a perpendicular bisector construction here and make the first arc. Then I'm going to make the second arc. There's my construction. I'm going to connect the dots and draw the perpendicular bisector. And now there is the line of reflection. And we know that it would cut these segments in half and meet at a 90-degree angle with both of them. And there's the line of reflection. Now let's look at some of the common reflections. So we will often reflect over certain lines, and we're going to go over that here. So for rules of reflecting, the first blank says, it says triangle ABC is the pre-image. A pre-image is like a starting point. I'm going to say is the starting point, or points, I guess. So are the starting points. I don't know about grammar, but something in there, it's the starting points. The coordinates of the pre-image for this specific example are A at 2, 3, B at 2, 1, and C at 5, 1. Now let's look at some of the common reflections. The first one says to reflect over the y-axis. So remember, this is the y-axis here. If I want to reflect over the y-axis, I'm going to count from A to my line of reflection. So here's the line of reflection. I go 1, 2. And then to reflect, I go that same amount on the other side. So now I'll go 1, 2. And here is where A prime should be. And I do the same for the other points. So for B to the line of reflection, I go 1, 2. And then from the line of reflection over, again, 1, 2. And there's where B prime should be. I'm going to do the same thing for C. I'm going to count 1, 2, 3, 4, 5 to the line of reflection. And now I'll count 5 in the other direction. 1, 2, 3, 4, 5. And here is C prime. Now I can connect these, and we should see a triangle that is nearly exactly the same in size, but it is facing the opposite direction because it has been mirrored. And there's our new triangle, A prime, B prime, C prime. There's our image. So down here, the coordinates of the image are A prime is at where? Let's see. A prime is at -2, 1, 2, 3, +3. So A prime is at -2, +3. B prime is at -2, +1. And C prime here is at -1, 2, 3, 4, 5, +1. So -5, +1. And let's compare these. Compare the A prime, B prime, C prime to the original A, B, and C. What is different between these ordered pairs? So just comparing A and A prime, notice the X coordinate has become a negative, right? Here, does that hold true for B? So the 2 becomes -2, and in C, the 5 became -5. So the X coordinate has changed signs. They all became negative. Well, now what's the same? Well, from A to A prime, notice the 3 stays positive, right? So the Y coordinate stays the same. Now the transformation rule we're about to write is the key to this section. For all of these common transformations, we have a common rule that will always work. So for this one, our pre-image coordinate might be x, y. So here's our pre-image. This is what we start with, like in A. And anytime we reflect over the y-axis, the image becomes -x, y. The x changes sign, the y stays the same. And that rule is really important. That's one that you probably want to write down somewhere special as one of those transformation rules. Now let's reflect over the x-axis. So I'll draw this up here. Remember, the x-axis is the horizontal line. So I'll do this in another color. When I reflect over the x-axis here, I'm going to count to the line of reflection. So I go from C to the line of reflection on the x-axis is 1. And then I go down 1. And there should be C prime. Okay, then we'll do the same thing for B. So for point B, it goes 1 down to the x-axis. Then I'll go down 1 more to find where B prime should be. And last, I'll do point A. So A goes 1, 2, 3 to the x-axis, and then I'll go 1, 2, 3 on the other side to find A prime. And now when I connect these points, that gives me our new triangle that has been reflected over the x-axis. So for this one, let's now list where the coordinates of the image are. So looking at this image, A prime is now at 2, 1, 2, -3. B prime is at 2, -1. And C prime is at 5, -1. All right, so I've written those down, and now let's compare them to the pre-image. How do I get from 2, 3 to 2, -3? Notice the y coordinate changes sign this time. Does that hold true for all of them? 2, 1 becomes 2, -1, and 5, 1 becomes 5, -1. So when we're looking at these points, what's different this time is that the y coordinate changes signs. Where now what's the same? The x coordinate is the one that stays the same. So for this rule, our pre-image ordered pair becomes x, -y, because this time it's the y that changes. So here's this one. Now, number 3 says reflect over the line y equals x. So up here, I'm going to sketch in where the line y equals x is first. So if you're familiar with the line y equals x, right? That's a linear line. It has a slope of 1, y-intercept of 0. So it should be, well, that was not great, but it was okay. That's a little bit better. There it is. So there's the line y equals x, right there in the diagonal. And we're going to reflect over this line. Now, to do this reflection, it's a little bit different than the ones before, because before we could just easily go to the line and over, right? This is horizontal and vertical. We would move horizontally or vertically, but now this is a diagonal. And so instead, we move in opposite directions. So when I go from A to A prime, I'm going to count from A, and I go to the right one, and now I'll do the opposite on the other side. So instead of going right one, now I'm going to go down one. So I switch directions, and that's where A prime should go. So for example, for C, if I go left 1, 2, 3, 4, now I'm going to go up 1, 2, 3, 4. There's C prime. So the opposites are up and left, down, and right. So whichever direction you move, you do the opposite. So for B, if I go up 1 to the line, I'm going to then go left 1 to find B prime. So you can move in any direction you want initially, as long as you're going towards the line, and just follow this rule for what you do then after. So if you move left, then go up. If you move right, then go down. If you move down, then go right, and then up, go left. Now I can connect these points to make our image for this one. So connect ones. And now we've got the image A prime, B prime, C prime. Now for this one, let's label the coordinates of the image. So now A prime is at 3, 2. So A prime is at 3, 2. B prime is here at 1, 2. And C prime is at 1, 1, 2, 3, 4, 5. All right, so let's compare these. The image to the pre-image. And if you don't remember the pre-image, so let's go back up. A is 2 comma 3, and now A prime is 3 comma 2. Think about what just happened. B is 2 comma 1, B prime is 1 comma 2. C was 5 comma 1, C prime is 1 comma 5. What do you notice? X and Y switch, right? The X before was 2 and Y was 3, and now X is 3 and Y is 2. Nothing changes signs, they just switch their order. So for the transformation rule for this one, we get the original pre-image XY becomes Y comma X. They just switch their order. So this one is also important as well.